This looks clean, but inside this washing machine, something invisible is happening. Your clothes are breaking apart, not into pieces you can see, but into thousands of tiny plastic fibers that go down the drain. You think you're just washing your clothes, but you are unknowingly releasing synthetic waste. Most people think ocean plastic comes from bottles, bags, and trash on beaches. But plastic pollution is not always big enough to see. In fact, some of the most pervasive plastic waste comes directly from the clothes we wear every single day, washing down our household drains in massive, microscopic numbers. Clothes made from polyester, nylon, acrylic, and fleece are incredibly common. But these materials are basically made from plastic-based synthetic polymers derived from petroleum. When you wear synthetic fabrics, you are essentially wearing spun plastic threads, chemically identical to the plastic containers we routinely try to avoid and recycle. When you wash these garments, friction, water, and detergent cause tiny fibers to break off. Because synthetic yarns are made of thousands of individual extruded filaments, mechanical wear easily fractures these delicate plastic structures. These fractured pieces are called microfibers, and they easily detach from the weave during laundry. Inside the drum, the constant physical agitation of the wash cycle acts like a microscopic grater. Higher spin speeds, rougher water currents, and aggressive detergents weaken the synthetic fibers further. The longer and more intense the cycle, the more these plastic fibers are shed from the fabric and suspended in the wastewater. Once separated from your clothes, these microfibers go down the drain with the dirty laundry water. They leave your home through the domestic plumbing system, entering a vast network of subterranean pipes. Millions of these tiny plastic particles are swept away from your household every time you run a single cycle. This wastewater eventually reaches municipal treatment plants. While these facilities are highly efficient at filtering out larger solids and organic matter, they are not designed to capture microscopic synthetic fibers. Trillions of these invisible plastic threads slip straight through the treatment systems, completely bypassing standard filtration barriers. With no further barriers to stop them, the escaped microfibers flow directly into local river systems and lakes. From there, currents carry them downstream, eventually emptying into the global marine environment. What started in your washing machine has now successfully completed its journey into the open ocean. Once in the ocean, microfibers don't just float near the coastlines. Ocean currents and deep-sea thermal systems act as global distribution networks, transporting them across thousands of miles. Scientists have detected these synthetic fibers in remote, uninhabited regions of the planet, including the Arctic Ocean and the deepest ocean trenches. At the base of the marine food chain, zooplankton and other primary consumers drift through the water column. Because microfibers are roughly the same size as organic particles, these tiny organisms mistake the plastic threads for food. They consume them, introducing synthetic polymers directly into the biological food web. This is where bioaccumulation begins. When small fish eat the zooplankton, they ingest the microplastics stored inside them. As larger predators consume those small fish, the concentration of synthetic plastics increases at every trophic level. The plastic from our laundry is moving steadily up the global marine food chain. The scale of this problem is staggering. Studies suggest that a single wash load of polyester garments can release hundreds of thousands of individual microfibers. Globally, this adds up to an estimated 500,000 tons of synthetic microfibers entering the marine environment every single year. Not all fabrics shed at the same rate. Tightly woven materials, like high-quality nylon jackets, release relatively few fibers. In contrast, loosely spun synthetic knits and fluffy synthetic materials shed vast quantities of microplastics. The structural design of our clothing directly determines how much plastic waste it produces. Fast fashion relies heavily on cheap, rapid manufacturing processes. To keep costs low, synthetic fibers are often spun quickly, resulting in weaker and shorter filaments. These structural defects mean the fabrics degrade much faster, shedding significantly more microfibers during each laundry cycle compared to high-quality, durable garments. Among the highest shedding garments are the cozy fleece jackets we love. Fleece is made by brushing synthetic polyester fibers to create a soft, fuzzy texture. This brushing process breaks many of the yarns, leaving millions of loose plastic fibers exposed and highly susceptible to washing out in the laundry. Controlled laboratory experiments have isolated washing machine discharge to measure this exact output. Researchers wash specific fabric types under standardized conditions, filtering the wastewater to count the fibers. These empirical studies prove that household laundry is a primary driver of the microscopic plastic pollution found in public waterways. The problem isn't just the physical plastic. Microfibers act like tiny chemical sponges. In the ocean, they absorb toxic chemicals, heavy metals, and persistent organic pollutants from the surrounding water. When marine life ingests these fibers, they also ingest a concentrated dose of hazardous chemical toxins. While the long-term impacts on human health are still being actively investigated, the ecological consequences for marine life are clear. Ingested microfibers can cause physical blockages in the digestive systems of small organisms, leading to reduced feeding, lower energy levels, and reproductive challenges. The good news is, you don't have to throw away all your clothes. You can immediately reduce microfiber pollution by adjusting your laundry habits. Wash only full loads to reduce friction, use cold water cycles, select gentler spin speeds, and wash your synthetic garments only when absolutely necessary. You can also use specialized laundry accessories to capture microfibers at home. Washing bags designed for synthetics keep garments contained, reducing friction and trapping shed fibers inside the bag. Alternatively, reusable laundry balls can be thrown into the drum to collect loose fibers before they leave the machine. For a more robust solution, external microfiber filters can be installed on your washing machine's drain pipe. Studies show these filters can capture up to 90% of polyester microfibers from household wash water. They prevent these tiny plastics from ever entering the public sewer system. At the industry level, textile engineers are developing innovative solutions. They are experimenting with yarn coatings that prevent fiber breakage, longer fiber extrusion techniques, and biodegradable synthetic alternatives that break down safely in marine environments. These advancements aim to eliminate the problem during the fabric manufacturing process itself. Legislative actions are also beginning to take shape worldwide. Several regions are proposing or enacting laws that require all new washing machines to be equipped with built-in microfiber filtration systems. These policy shifts aim to make active microfiber containment a standard feature in every modern household. Our daily household routines are directly connected to global ocean health. Every load of laundry we wash has microscopic consequences. Solving this hidden environmental crisis requires a combined effort from conscious consumers, responsible fashion brands, appliance manufacturers, and proactive government regulators. We all have a role to play. The next time you run a load of laundry, remember the invisible journey of your clothes. By making simple changes to how we wash and buy clothing, we can collectively keep tons of plastic out of our oceans. Support systemic solutions and share this video to raise awareness about microfiber pollution. Subscribe to our channel for more deep scientific investigations.